Welcome back to VMware View Administration Training. In this lesson, we'll cover Troubleshooting VMware View. The topics that we're going to talk about in this lesson include the common failure points within View, so that you can have an understanding of where View tends to fail and be prepared with some of the solutions. We'll talk about the connection procedures and what steps View goes through when connecting to a desktop. I'll give you a quick rundown on how linked clones work and the different pieces that make up a linked clone desktop. We'll talk a little bit more specifically about some of the firewall ports that will need to be opened for VMware View to work. We'll talk about the special protocol that VMware View uses, called PC over IP, and some things you can do to tweak it for better performance. I'll give you a quick rundown on the log locations for all the different components of View, and we'll also talk about how you can collect the diagnostic information that can be sent to VMware support. We'll finish up by walking through a few troubleshooting scenarios and demonstrations on where the log locations are and how to create the diagnostic bundles. There are several different places where VMware View can stop working and cause problems for you and your users. In this section, I'll cover a few of those with you and give you an understanding of why they might fail and how to correct them. The first is network connectivity between the client and the connection server or security server. The first thing you'll usually want to check when having problems between the client and the server is to check the proxy and firewall settings. You'll specifically want to make sure the proper ports are open, which we'll cover later in this lesson. You'll also want to verify that DNS resolution is working correctly, since most users will connect using a DNS name. If DNS isn't a possibility, you may need to use the IP address in the external URL field within the connection server or security server configuration in the VMware View Administration Console. If you're trying to use the PC over IP secure gateway, make sure it's enabled and that you've set the proper IP address in the PC over IP external URL field within the View Administrator console. Next is connectivity between the desktop and the connection server. Again, check proxy and firewall settings. Generally, it's pretty uncommon to have a firewall between the desktops and the connection server. But when using the security server, connections can be made directly between the security server and the desktop, and it is common to have a firewall between those two. Next, make sure both the connection server and the desktop can ping each other using the DNS name. You'll also want to make sure that the desktop received a valid DHCP IP address. It's not uncommon for a View infrastructure to use up a lot of DHCP IP addresses. And if your DHCP scope isn't big enough, it's possible that desktops won't receive their IP address properly, and therefore won't be able to be contacted by the connection server. Next, failure to create a pool. First thing you want to do is make sure that the vCenter service is available, and that the web service is also running. If those are okay, make sure that the connection server can ping the vCenter server, both by IP and using DNS resolution. Next, you want to check the data store that pool was configured to use, to make sure there's enough space available for it to create desktops. The service count that was created to connect between View and the vCenter server needs to have proper permissions to create the pool, access templates, access the customization specification or the parent VM, and to access vSphere itself. These permissions are well documented in the View Administration Guide. If vCenter is overloaded and can't handle the number of desktop requests that View is sending its way, you can reduce the maximum number of concurrent provisionings and the number of power operations that View will send to the vCenter servers. These can be configured in the View Administrator when setting up the vCenter server. Reducing these values will throttle View back so it doesn't hit the vCenter server quite as hard. Next, VMs can get stuck in a provisioning state. Usually this is due to a connection server being rebooted, but could occur if connectivity between the vCenter server and the connection server is dropped. In this case, you can usually delete the virtual machine and allow View to recreate that desktop. Next, a VM stuck in the customizing state is likely due to insufficient free space on the data store. Whenever you power on a virtual machine, a swap file is created on the data store to handle any swapping that the virtual machine may need to do. Freeing up disk space is the easiest way to get this virtual machine to power on and complete its customizing steps. You could also consider migrating the VM to a different data store, or simply deleting the virtual machine and reducing the size of the pool. If you're having problems redirecting USB devices, it's recommended that you use the PC over IP protocol instead of using RDP, so make sure that the user is connecting the proper way. PC over IP is better built to handle USB redirection than RDP, which simply redirects it down a different channel. Next, make sure USB redirection is enabled in the View policies, both globally and on the individual pools. When looking in the log files for the virtual desktop, look for entries that contain WSSM_USB, which will give indications as to what the problem is with redirecting the USB device. Next, check the client logs for entries with WSWC_USB. On the virtual desktop, you'll also want to check to make sure that the VMware View Virtual USB Device Manager device and the VMware View Virtual USB Hub device have the proper drivers installed and that they don't have any errors. Similarly, on the client device, you'll want to make sure that the VMware View generic USB device driver is working properly and that the USB driver for that redirected device is installed and enabled on the client device itself. So that was a few of the typical places where VMware View has problems, and some easy solutions for solving those common problems. Next, let's talk about the procedure that connecting to a desktop goes through. I find it's important to understand procedures like this for troubleshooting purposes, so you know what to look for and help narrow down where the problem might be. The first step is the client connecting to the connection server, along with a username and password. The connection server then uses this username and password to authenticate the user and figure out which desktops they're entitled to use. This list is sent back to the client machine, and the user is asked to select one of them. At that point, the client will initiate a PC over IP connection to the desktop. When using a two-way communication, the client on the end-user device and the agent in the virtual desktop will negotiate back and forth with one another to actually create the PC over IP session. Once the session is negotiated, the actual PC over IP data channel connection is opened from the agent in the virtual desktop to the end-user device. This is a common place where firewall settings can get misconfigured. Once the actual data channel is connected, the control and data session connection will be open between client and agent. Then a PC over IP heartbeat connection is made between the two devices. And finally, a heartbeat session between the View client and the View connection server will be opened. And then at that point, the user will have a desktop connection. Now let's talk about how linked clones work. Again, understanding the basics of how the system functions will help you with troubleshooting it. So all linked clone desktops work by actually using a replica VM. The linked clone desktop itself consists of a delta file that will contain any changes that are made by the virtual desktop and are not written back to the replica VM, since that is a common base image that all the desktops in the pool will be using. The replica itself is a thin provisioned, full clone of the parent VM at the point in time in which the snapshot that is selected was created. By default, each data store that the pool is configured to utilize will have its own replica created for that particular snapshot. You do have the option when creating the pool to place the replica on one specific data store, in which case every desktop in the pool will use that one replica on that single data store. This does provide a potential single point of failure for the entire pool, but can be used to tier your replica to run on a higher end set of disks, providing better performance for everyone using the pool. If you have multiple pools that are using the same snapshot on the same parent VM, all the desktops within both pools will utilize the same set of replicas. This will greatly speed up the deployments of the subsequent pool. It does occasionally happen that when a pool is destroyed or recomposed, that the replica is not properly cleaned up and becomes an orphan VM. and will need to be manually deleted. In order to view these replicas, you need to go under the Edit menu and select Client Settings. In that Settings window, you'll see a checkbox for Show View Composer Virtual Machines. Checking that checkbox and clicking OK will display a directory that contains all the replica VMs. These replicas are protected entities within vCenter, which is why they're hidden in the first place. This prevents a vSphere administrator from accidentally powering on or deleting a replica VM. In order to delete the replica VMs, you need to unprotect them, which can be done using the SVI config tool and using the unprotect entity operation, providing the URL for the vCenter, including a username and password, the path to the entity that you want to unprotect, and if you want to unprotect all of the replica VMs, you'll need to provide the recursive equal true flag as well. This will then allow you to treat the replica as if it were a normal virtual machine. Now let's talk about the ports that are used throughout the connection process. The first set of ports are TCP 80 and 443, commonly known as HTTP and HTTPS. These ports will need to be open for connections from the client to the connection server and security servers, which will handle all the communication of creating a desktop session. Next, the security server needs to talk to the transfer server over these two ports to handle any data transfers of local mode desktops. Finally, the connection server will need to talk to the vCenter server using HTTPS. View will do all of its manipulation of virtual machines and creation of pools through the vCenter web services. The next port is TCP port 8009, which is used for the security server to connect and communicate with the connection server, which of course is the data path for any desktops connecting from the internet. TCP port 4001 needs to be opened for the security server to talk to the connection server for the same reason. Also, the virtual desktop needs to be able to talk to the connection server over TCP 4001, which provides a data communication channel for the agent to provide its status messages of its current state. When using RDP to connect to a desktop through the security server, ports 3389, port 32111, and port 9427 will all need to be open between the security server and the virtual desktop, because when using RDP through the security server, the actual connection to the desktop is made from the security server directly to the desktop. When using PC over IP to connect to a desktop, you'll need to open up TCP ports 4172 and 32111, both between the client and the connection server or security server, and from the connection or security server to the desktop. PC over IP also requires UDP port 4172, which is used bidirectionally between the client and connection or security servers, and also bidirectionally between the connection and security servers and the desktop itself. This is your main PC over IP path for the actual desktop session data. Finally, TCP port 4100 is used between the different connection servers. Best practices indicate that there should be no firewalls or WAN connections between connection servers, so this port is generally not needed to be configured. Now let's talk about performance tweaks that you can use for the PC over IP protocol. The protocol itself is self-adapting, so tweaking shouldn't be necessary unless there's a specific problem you're trying to solve. The most important thing you can do to enhance performance of a desktop is to reduce effects and animations within the virtual desktop, since less changes on the screen would mean less data needing to traverse the network. Before starting to tweak your PC over IP performance, make sure to review the log files first, since this will indicate where you should probably start tweaking. To tweak the PC over IP protocol, you'll need to use the provided ADM template that you can find on the View Connection server in the installation directory under Group Policy Files. The maximum bandwidth is the most amount of kilobits per second that a PC over IP session will utilize. This has obvious advantages when using WAN links that may be limited in bandwidth, but could reduce packet loss across the LAN that may not have QoS or non-blocking technology built into the network. The bandwidth floor is the minimum amount of bandwidth that the PC over IP session will tolerate. MTU size determines the size of the packets that View will send out across the network. While this could help with high latency links so that you can push data across a little bit more efficiently, it could also result in higher fragmentation of the packets when the network isn't properly configured end-to-end to support these larger MTU sizes. The minimum image quality determines how good the video should look on the screen. By lowering the minimum, you actually can increase the number of frames that can be sent in a second. This is a delicate balance between the smoothness of the connection and the quality of the images that will be seen on screen. The maximum initial image quality can be used to determine how good the images will look on screen when they're first shown. By lowering the maximum, you decrease the size of the spikes that you would see in bandwidth when a new piece of the desktop is shown on the screen. It's generally recommended that you play with this setting before limiting bandwidth or adjusting the minimum image quality, because ultimately the maximum initial image quality only affects the screen when it first loads. PC over IP is a progressive build technology, so as time goes by, the quality of that image will increase. The maximum frame rate setting can be used to determine how smooth the video of the session is. By lowering this, you will use lower bandwidth, but motion of items on screen and videos may look choppy. You can also set a limit on the audio bandwidth, which will lead to lower audio quality, but help reduce the amount of bandwidth. As a side note, unless audio is absolutely required, you can completely disable it on the desktop, so that no bandwidth is used at all. Finally, you can adjust the encryption algorithm that is used for PC over IP. The salsa encryption algorithm is generally recommended since it is a faster encryption algorithm. When errors occur, the first thing you'll want to do is look at the log files to determine where the problem is actually occurring. Depending on the component we're looking at, the log file is located in a different spot. First, the agent, connection server, security server, and transfer servers will all store their logs in the same place. When using Windows XP in the virtual desktop, or Windows 2003 for the connection, security, or transfer servers, the log files are located under the All Users profile in the Application Data VMware VDM Logs directory. When using Windows Vista or Windows 7 for the virtual desktop, or using Windows 2008 or 2008 R2 for the connection server, security server, or transfer server, these logs can be found under the C Program Data VMware VDM Logs directory. On the client machine, when using Windows XP or Windows 2003 as a client operating system, the log files can be found under that particular user's profile in the Local Settings Application Data VMware VDM Logs directory. When using Windows Vista 7 or 2008, these log files are located under the user's profile under App Data Local VMware VDM Logs. On our vCenter server, where we have the View Composer installed, the log files can be found in the VMware View Composer Logs directory under either the All Users Application Data folder on Windows 2003 or directly in the All Users directory on Windows 2008. If you come to the point where you can't figure out the problem using resources available out there, you may need to open a ticket with VMware directly. As part of that ticket, they'll probably ask for a diagnostic bundle. This information bundle will aid VMware with troubleshooting your particular problem. How you create this diagnostic bundle depends on which component, so let's go through each one individually. We'll start with the View agent. The bundle can be created by running the VDM admin command you see on the screen. This command needs to be run from the connection server, which will then contact the agent to generate the bundle. On the View client, you need to click the Options button and then click the Support Information link. That will open up a window that contains information about the client itself. It also provides a button called Collect Support Data, which will then ask you for confirmation that you want to create the bundle. A command window will then appear, showing the progress of this collection and creation of the bundle. It will prompt you for any relevant connection server URLs that you're trying to use the client to connect to. This is because it will actually try and make the connection and record any data about that connection should it fail. Next, View Composer. You need to start by going to the View Composer installation directory in a command prompt. You can then run the cscript command that you see on your screen. For the View Connection Server, you have to bump up the level of logging by using the Set View Connection Server Log Levels application found in the Start menu. You then complete whatever tasks you want them to diagnose. And finally generate the log bundle by using the Generate View Connection Server Log Bundle command on the Start menu. Finally, you can use the support.bat command as well, which can be found in the installation location for the agent, client, and connection servers under the DCT directory. So now let's actually take a look at what it looks like to troubleshoot a problem desktop. In our View Administrator, we're currently looking at the desktop's inventory, specifically at the problem desktops. In here you'll see that we have two different desktops that are showing problems. Let's start with the Retail Kiosk 3, which is showing as an already used. If you remember, already used means that the desktop has been used, is configured to be deleted or refreshed on logoff, but for some reason that process hasn't occurred. Let's start by taking a look at the settings for the pool. Over on the right here, you'll see the Delete and Refresh Desktops on Logoff is set to delete immediately. Let's go back to our problem desktop. So this desktop was used, but for some reason wasn't refreshed immediately. This could happen when an administrator logs in through the vSphere client directly onto the machine. View will recognize that the user has logged on and then logged off, but it doesn't detect it as a log off like it normally would if the user was coming in through the View connection. To solve this problem, we simply need to select this desktop and click the Remove button. This particular pool is not using persistent disks, so we'll just tell it to go ahead and delete any persistent disks. As we refresh the screen, we'll see that the desktop is now deleted. Let's switch back to our pool and see what the inventory currently has. Retail Kiosk 3, which was our problem desktop, is now in a deleting status. Retail Kiosk 4 is already being created and configured for use with View to replace Kiosk 3 that we just deleted. So the pool is automatically recovering for that particular issue. Refreshing our dashboard, we'll see that our problem desktops are now set to 1. Heading back to our problem desktops view, we see Retail Kiosk 4 listed in here as a problem desktop with an agent unreachable status. That's okay for now. This will be a temporary problem while the virtual machine is being created by View. So let's move on to Purchase 4 desktop that shows an agent unreachable as well. Usually this means either a networking problem or the service within the virtual machine has been disabled. Since we don't have a rash of virtual desktops that are having issues talking to the network, it's probably something within this one particular VM. So let's switch over to our vSphere client and take a look at this desktop. In our vSphere client, we've selected Purchase 04 desktop. And we'll go ahead and open the console for this VM. We'll log in using the administrator account. And take a look at our Services control panel. Open up Computer Management and take a look at Services. Scrolling down, we can see the VMware View agent is currently in a stop state. We'll go ahead and start the service and switch back to our View Administrator console. Then we can refresh our problem desktop screen. we'll see the status is now an unassigned user connected to the desktop. And this user is the domain administrator account. So it's now talking to the agent, but it's detected that a user who is not assigned to this desktop is currently connected and is currently logged in. We can solve that problem by simply logging off. One more refresh will show that we no longer have any problem desktops. Let's take a look at our dashboard and see what else we have going on here. We do have one VM still in a provisioning state, which is our admin 01. Now this particular VM has been in the provisioning status for at least an hour now, based on comments we've been hearing from other admins. So we've determined that this VM is probably stuck in a provisioning state. We recently had a restart of our View connection server, which may explain why this VM has gotten stuck. To solve this, we'll click the Remove button to delete the virtual machine. Switching back to our administrative pool, on the Inventory tab, we can see admin 01 is currently deleting. Refreshing our inventory view will show admin 01 is now deleted. Refreshing again, and we'll see that a new admin 01 is being deployed. Refreshing one more time, we see that the status is now in a customizing phase, which is one step beyond provisioning, so it looks like this virtual machine will be good. So that's a quick view of how to deal with some problem desktops. One advantage of running a floating linked clone pool is many of the problems can be solved by simply deleting the desktop. If it's a problem with an individual desktop, that'll usually clear up the error and new desktops will be deployed in its place. In these situations, remember to watch out for the Stop Provisioning on Error setting, because this could prevent virtual machines from deploying when a single VM has a problem provisioning. Next, let's take a look at what a linked clone looks like under the covers. In order to see the replicas, you need to go under the Edit menu and select Client Settings. In the Client Settings, there's a checkbox to show the View Composer virtual machines. When we click OK, we'll see a new folder show up in our VMs and Templates view called VMware View Composer Replicas. Inside there, we'll see 3 different replicas, which represent the base VM for 3 different parent VM snapshots. Since these replicas are protected, we can't edit settings, migrate, delete from disk, or power on or power off this virtual machine. This is because Composer creates these replicas as protected entities within vCenter, which is also why they're hidden to begin with. Since these replicas can't be modified by default, and occasionally provisioning can break and leave a replica out here when it doesn't need to be, it is sometimes necessary to unprotect the replica and delete it manually. So let me show you how to do that real quick. This is done on the command line using the SVI config tool, which exists in the VMware View Composer installation directory. So let's change to that directory right now. In this directory, you'll see the SVI config.exe tool, which is the one we want to use. And the first parameter we want to provide it is the operation parameter, so that it knows we want to unprotect an entity. Next, we need to provide it the URL for the vCenter server, specifically the SDK directory. Next, we need to provide a username and password for an administrator within vCenter. The next parameter is the inventory path parameter, which defines which object within vCenter we want to unprotect. For this example, we're going to provide the path to the VMware View Composer's replica folder. This will allow us to recursively unprotect all three of the replicas. Finally, we'll provide the recursive parameter and set it to true. Now, launching this command is going to connect to the vCenter server and unprotect our replicas. Here we can see it successfully unprotected 4 entities, the folder, and all 3 of the replica VMs. Switching back to our vSphere client, we now have the option to edit settings, migrate, delete from disk, and power on the virtual machine. We could now delete this replica if that's what our intention was. We don't want to do that in this case, so let's go ahead and reprotect these entities. The command is almost identical, so we'll modify the previous one. To protect the entities, we simply change the operation parameter to say protect entity instead of unprotect. Otherwise, all the other parameters can stay the same. And now all 3 of our replicas are again protected entities. So now we can no longer do any operations against it. Now let's take a look at one of the linked clones. We'll look at the Purchase 02 desktop. Selecting the Snapshot Manager for Purchase 02, you can see that VDM, which is the code name for VMware View, has created a VDM Initial Checkpoint Snapshot. This snapshot is taken after the customizing phase is completed. This drastically speeds up the refresh time for a linked clone desktop. With this snapshot, View Composer can simply revert to the snapshot and not have to go through the whole quick prep process any longer. Now let's take a look at the disk files that Purchase 02 has. This pool is deployed across 2 different data stores, the iSCSI 1 and the NFS 01. Let's start on the iSCSI 01, where we'll browse the data store. We'll select Purchase 02 in the list, where we can see all of the files that make up this one virtual machine, including the VMX file, which defines the configuration, and several VMDK files. This file that ends in 000001 is the snapshot file. You'll also see a disposable disk that we created for this pool, and an internal disk, which contains some specific data that Composer will use each time the desktop is refreshed, but is hidden from the user otherwise. To see the persistent disk that we created for this pool, we need to go to the NFS store and browse the data store. On this NFS share, you'll see many ISO files, but at the bottom are 4 disks that are created for each of the desktops in this pool, including one for Purchase 02. Those are all the files that it takes to make up a VMware View Composer-based desktop. So that's what a linked clone desktop looks like. Let's move on and take a look at the log file locations for each of our different components. Let's start by connecting to a desktop so we can see some of the entries. Now that we're connected to Alexander's View desktop, let's take a look on the C drive for the log files for the View agent. In Windows XP, the files will be under the Documents and Settings directory. But if you're using Windows Vista or Windows 7, you'll need to go into the Program Data directory, which is equivalent to the All Users under Documents and Settings. We'll then go under Application Data, into VMware, and then VDM, where we'll find the Logs directory. In here are a couple different log files. You got your standard log file, which is rolled over by date. You've got a debug log file, and you have a PC over IP, both an agent and a server. Let's go ahead and look at the most recent PC over IP server log file, where we'll find information about this particular login. In this log file, you'll find many pieces of information about the PC over IP connection between the client and the agent. It also shows the startup of PC over IP server, the fact that it's running as a software PC over IP host. You could see the IP address that it's bound to. As you can see, it collects a lot of data about this connection on many different facets. Here you can see some information about the audio connection and the video connection. There's some information about compression and the KVM between the two. There's some encoding information about the video being sent to the client device. This log file is the one you want to go to when troubleshooting any issues you're having with the PC over IP connection. You can also look in the standard log file. You can see with this entry right here is the start of our PC over IP connection to this desktop. Now we'll switch over to our VMware View connection server and take a look at its log file. We'll start on the C drive and go under the Program Data directory. Inside VMware, VDM, where we'll find the Logs directory. We again find a standard log file, a debug log file, and in this directory, log files for the PC over IP security gateway. Let's take a look at our standard log file. We'll scroll down to the very bottom, where we could see entries listed as both info and as warnings. On this entry, we can see that Alexander has connected to a machine, admin03dt. Back to Alexander's desktop, let's go ahead and disconnect from his desktop. And now that we're on the client machine, we can take a look at its log file. This being a Windows 7 client, we'll go into the users directory and look at the specific user account. In the app data directory, inside the local directory, we'll find a VMware folder, then a VDM folder, and then finally our logs directory. Here we can take a look at the log file for the VMware View client. Again, we'll see a series of info and error and potentially warning entries in this log file. Specifically, we can see connecting to client, showing a client connecting to a desktop. Finally, we'll switch over to our vCenter server, where we can take a look at the log files for the View Composer functionality. On the C drive, we'll take a look in the Program Data directory under VMware, View Composer, where we'll find a Logs directory. Inside this directory, you'll see 3 different log files, the most important of which is the View Composer log. In here we'll get entries that provide information, error, and even fatal errors. Scrolling down to the end, we can see many different operations occurring. One of particular interest right now is the destroy SVI clones operation, which is the result of us logging off of a desktop in a pool that's configured to delete on logoff. So that was a quick view of the log files that exist within the View infrastructure. Clearly, these log files will be an invaluable resource when troubleshooting the desktops. How to generate support bundles varies from one piece of the infrastructure to the next, so let's walk through each of them. We'll start with the View connection server. To collect log data, we need to go up to the All Programs menu in the Start menu. Under VMware, where we want to set the View connection server log levels. It gives us an easy interface for determining whether we want to go info, debug, or a full level of logging information. As we go up from info to full, we'll collect more data, but generate much larger log files. This could potentially have an impact on the performance of our connection server. We'll go ahead and set it to 2. We've now successfully set our logging to debug level. Now we can perform whatever operations we're trying to troubleshoot. Once those are complete, we come back into the All Programs menu, and we can use the Generate View Connection Server Log Bundle. So up to this point, the diagnostic bundle has captured a ton of great information, including log files and configuration details of View. Now we have the option to generate diagnostic dumps of the different processes running on the View server. Let's go ahead and do that. Now that the process is complete, we can go and take a look at the zip file, which you can see here contains a lot of different folders and files, including some XML files, and even an export of the database itself. While we're on the connection server, we can go ahead and run a diagnostic bundle for the View agent. This is done using the VDM admin tool. We'll provide a capital A for the first parameter, a lowercase d, and then identify which pool we want to collect data from, which in this case is our administrative pool. We'll then use a lowercase m parameter to define which desktop specifically we want to pull data off of. In this case, admin02. The next parameter will identify the fact that we want to collect the diagnostic information bundle. And finally, provide an out file parameter to determine where that zip file is going to be placed. Now that the process is complete, let's take a look on our C drive for the zip file. Inside the zip file, we'll again find a series of logs, text files that represent the configuration. Switching over to our vCenter server, let's generate the bundle for the View Composer. We'll again do this from the command line, specifically in the View Composer installation directory. We'll run a cscript command to execute the svi support.wsf. Now that this process is completed, let's go take a look at our desktop. Here again we can find a whole bundle full of logs and text files that represent the configuration of this component of View. Finally, let's take a look at our View client. Which provides us access to the bundle through the actual client interface by using this Options button and then clicking Support Information, where we first get a view of some information about the client itself. More importantly, provides us access to a button to collect the support data. As part of the process for collecting diagnostic data for the View client, we have to provide access to the View connection server itself so that it can attempt to make a connection to collect better information for the bundle. It does give us the ability to enter multiple connection servers if we're having problems connecting to multiple ones. We're not, so we'll go ahead and leave this field blank. Now we get the option to collect the dump files that this process has found residing on this client machine already. We'll go ahead and collect those in the bundle as well. We also get to choose whether or not to dump information about the processes that are running. Again, we'll select yes. Our collection is now complete. We can once again return to our desktop and take a look at the bundle. As usual, we find a series of text files and log files that contain great information about the configuration and how well this component has been working. Once you've generated those bundles, you can send those up to VMware as part of your ticket. VMware can then analyze the configuration and the logs that are collected in those bundles to provide them better information for troubleshooting your issues. There's obviously a lot to troubleshooting any application, and View is no different. This lesson can only go so deep into troubleshooting, so here I've provided you a bunch of resources that can help you learn to better troubleshoot View. The first is the VMware Knowledge Base, which is an indispensable tool when troubleshooting any issues with any VMware products. Next is the VMware View Resolution Paths. VMware's been putting these together for many different products to help guide you through the troubleshooting process. These are created and based on the knowledge of VMware Support Organization. Next is the View Administration Guide, which of course contains all the information you need for managing a View environment. Finally, I've provided you a URL for the View Architecture Planning document, which contains some great information about all the ports needed, how to set up firewalls, and other infrastructure setup that needs to occur for View to work properly. So let's wrap up this troubleshooting session. We started by looking at some common failure points, issues that are commonly seen within the View infrastructure, and what the common resolution is for them. I then walked you through the connection procedures so that you can truly understand what happens when a user connects to a View desktop. We covered the operation of linked clones and the different steps that are taken in order to create them. I gave you a listing of the different ports that View needs, and that should be checked whenever connection problems occur. When dealing with PC over IP, there are several settings that you can use to tweak the performance of it and its bandwidth requirements. Logs, of course, are the most important tool you can have when troubleshooting an issue. So I give you a listing of where all of those logs can be found at. When working with VMware support, they're likely to ask you for diagnostic information. For each component of View, there are different steps that you take to create this information, but in the end, they'll collect the configuration and log files for that particular component, which can then be uploaded to VMware for use within the support organization. And we finish up this lesson by walking you through some of the troubleshooting topics we discussed in this lesson, including showing you a live environment with some actual issues and how to solve them, the different components and files used to create link clones, an actual view of the locations and log files within the View infrastructure, and a walkthrough of how to generate the support bundles. I hope this information will be useful for you when troubleshooting your own infrastructure. Thanks for watching, and we'll see you in the next lesson.